Hello class, we are starting our trig unit. So before we do that, let's start with a little right triangle theorem. We remember a squared plus b squared equals c squared for any right triangle. So with this formula we can find the missing side. So if we have any two sides, we can use this formula to find the third side. So we have, for number one, let's call that C. So we know that 5 squared plus 12 squared is going to be equal to C squared. So that gives us 25 plus 144 equal to C squared. We can add 25 plus 144, which gives us 169 is equal to C squared. We're able to take the square root of both sides, and that leaves us with 13 is equal to C. Number two, same thing, ladies and gentlemen. So we'll call it A. So I know that a squared plus 5 squared is equal to 110 squared. Can we simplify that? So we have a squared plus 25 is equal to 100. We can subtract the 25 from both sides, and that gives us a squared. A squared is equal to 75. Again, we can take the square root of both sides, and that gives us A on the left, and on the right, this is 75 is the same thing as 25 times 3. So we know 25 is a perfect square. We can pull that out. So that gives us 5 square root of 3. Excellent. So with trig, ladies and gentlemen, now we only need to have one side of a right triangle to figure out the other sides. But we do need to have at least one other angle. So we have a right triangle, but we have one additional angle. So we look at the triangle in perspective of the angle. So this, in respect to the angle, that is the opposite side of the triangle. The adjacent side is always next to the angle. It's always next to the angle. And the hypotenuse is always the longest side of the triangle, and the hypotenuse is always opposite of the right angle. Okay, the hypotenuse is always opposite of the right angle. So we have in respect to the angle, this is the opposite side. We have the adjacent side, which is next to the angle, and the hypotenuse, which is across from the right angle. So when we first look at trig functions, we have them in relations to two different sides. The first trig function is the sine function. The sine, if we have the opposite and the hypotenuse, in relation to the angle, then we will use the sine function. We'll use the sine function. Okay? If I have the adjacent side and the hypotenuse in relation to the angle, then I will use the cosine function. to set up my equation. Okay. And then lastly, if we have the opposite, and the and the adjacent in relation to the angle. So we start with the angle. We have the opposite side and the adjacent side in relation to the angle. Then that will be the tangent function. That will be the tangent function. So let's see if we can set this up. So in relation to the theta and the angle theta, we can use the angle, or we can use the measure of the angle. So in relation to the angle, the sine, so we're going to, from this angle, we know that this is the opposite side, we know this is the adjacent side, and this side is the hypotenuse in relation to the angle. So that's the first thing we need. Then to do the sine function, we know sine, let's give us a little reminder. So we know sine, the sine of the angle is equal to opposite over hypotenuse. The cosine of the angle is equal to the adjacent over the hypotenuse. And the tangent of the angle is equal to the opposite over the adjacent. So those are our functions that we need to work with. So the sine of theta would be, the opposite side is 4, and the hypotenuse is 5. So we just write in the fraction. The cosine of theta is the adjacent over the hypotenuse. So the adjacent side is 3, and the hypotenuse is 5. The tangent of theta is the opposite over the adjacent. That will give us the tangent of theta. Now, if we were looking from the perspective of A, angle A, if we're looking from the perspective of angle A, then we know that this is the opposite side. This one is the adjacent side, and that this is the hypotenuse. Looking from angle A, this is the opposite, the adjacent, and the hypotenuse. So the sine of A, again, sine is opposite over hypotenuse, would be 3 over 5. The cosine of A, which is adjacent over hypotenuse, so it would be 4 over 5. The tangent of A, which is opposite over adjacent, would be 3 over 4. Okay. Next. So, same thing. Looking from the sine of theta, we're looking from the perspective of theta. From this perspective right here, from this perspective, once again, this is the opposite side, this is the adjacent side, this is the adjacent side, and this would be the hypotenuse. So, the sine of theta would be 5 over 13. The cosine of theta would be 12 over 13. The tangent of theta would be 5 over 12. Okay. From the perspective of angle A, this is the opposite side. This is the adjacent side, and this is the hypotenuse. So, the sine of A, which is opposite over hypotenuse, would be 12 over 13. The cosine of A, which is adjacent over hypotenuse, would be 5 over 13. The tangent of A is opposite over adjacent, which is 12 over 5. let's see if we can do it without the letters. So the sine of theta, we're looking from the perspective of theta. So from that theta, the sine of theta is going to be, again, opposite over hypotenuse. Opposite over hypotenuse, so it's going to be 8 over 10. The cosine of theta would be 6 over 10. The tangent of theta would be 8 over 6. The sine of A, so now we're changing the perspective that we're using. Now we're going to use this perspective. From angle A, the sine is opposite over hypotenuse, so that would be 6 over 10. Cosine of A would be the adjacent over hypotenuse, which is 8 over 10. And the tangent of A, which is opposite over adjacent, would be 6 over 8. So next, now that we know how to write the functions, we can write an equation based on the angle. This is my angle. I have the opposite. I have the adjacent. So what function is that? That opposite and adjacent is the tangent function. So I know tangent of theta, which is the angle, is equal to 2 over 5. So the next one. From the angle, this is the opposite, this is our hypotenuse. So which function is that? That is going to be the sine function. The sine function. So that's going to be the sine. Our equation is going to be the sine of theta will equal 3 over 5. Because we have to set up the equation. Number 3. Again, from the angle. This is my angle. So this is the adjacent side. This is the hypotenuse. So that's going to be the cosine function. So we know the cosine of theta is equal to 4 over 5. So we have to know which function we're going to use based on the information that's given. We have to determine the function. So we know the equation right. From this angle, this is the opposite side, this is the hypotenuse. What function are we going to use? Yes, we're using the sine function. You're going to use the sine function. So this is going to be the sine of theta equals 5 over 6. Again, from the angle of theta, we have the adjacent side and the hypotenuse. So what function uses adjacent and hypotenuse? Yes, that is the cosine function. So we have the cosine of theta is equal to 5 over 7. Again, from the angle perspective, this is the opposite. This is the hypotenuse. So we're using the sine function again. So this is going to be sine of theta is equal to 5 over 8. Good. So now that we know how to write equations, we can write the equation and then solve for x. So what function am I going to use? Based on the angle, this is going to be the tangent function. So the tangent of 20 is equal to x over 5. And then we're solving for x. We're going to multiply it by 5 to both sides. And then I can plug it in my calculator just like I see it. Number 2, I have the angle 35 degrees, and that'll be my perspective. So the 3 is the opposite, the x is the hypotenuse. So that's, again, that'll be the sine function. So the sine of 35 is equal to 3 over x. I need to solve for x. I need to get that x out of the denominator. So I'm going to multiply both sides by x. And then again, I need to get the x by itself. So I need to divide both sides by the sine of 35, because the opposite of multiplying is dividing. So x is equal to 3 over sine of 35. I type that in my calculator. I'll get 5.23. Number 3. I have my angle. It is a right triangle. So from the angle, I have the adjacent side and the hypotenuse. So that'll be the cosine function. Again, multiply both sides by 5. Type that into my calculator just like I see it. And I get the following. Good job, ladies and gentlemen. Please proceed to the check for understanding.